Good evening, my name is Mohammed Azam Khan, and today I'll be presenting my SRP on the effects of varying intensities of aerobic exercise on higher level thinking in athletic adolescents. Before I begin, I would like you to know a little bit more about me. I go by Azam since my 5 other brothers are also named Mohammed. I'm a senior at Tunstall High School, and I plan on going to the University of Virginia in order to study a pre-law program. Now you may be wondering why I chose this topic. First off, running has been a core part of my life for the past 4 years, and in that time frame, I ran at least 3,000 miles. Because of this, I was more than ecstatic to be able to study one of my favorite hobbies. Also, my mom has this theory. She has always claimed that I seem much less intelligent after coming home from a run. So in order to substantiate that claim, I've decided to center my SRP around it. And also, my research has applications for the real world as it could assist students in their academic test-taking endeavors. Before discussing the design of my experiment, some background is necessary. There are 2 central topics my SRP revolves around, the first of which being aerobic exercise, which may be defined as any type of exercise that results in higher level of oxygen consumption and higher heart rate levels. There are 3 different types of aerobic exercise: low, moderate, and high intensity. Low intensity is not important for the prospects of my study, as most research has found that it has no effect on the brain. Moderate and high intensity aerobic exercises, however, have both been shown to yield different results. Proteins are another essential factor to consider when observing cognitive function. Though there are a plethora of proteins in the body that may influence cognitive function, there are only a couple that are correlated with aerobic exercise, 2 of which being brain-derived neurotrophic factors, widely known as BDNF, and serotonin. The first thing to note about aerobic exercises is that speeds are not synonymous with intensity. Intensity is more so defined by a person's maximal heart rate. The max heart rate is found by subtracting a person's age from the number 220. Moderate intensity aerobic exercise constitutes at 60% of this number, whilst high intensity is 80%. And also, both intensities of aerobic exercises have been shown to yield different results on the brain. Moderate intensity aerobic exercise has been shown to either have no effect on or improve lower level cognitive processes such as memory and reaction time, whilst high intensity aerobic exercise has been shown to depreciate, have no effect on, or improve lower level cognitive processes such as reaction time and inhibition. The regulative factors that BDNF and serotonin have on the brain are essential to understand in order to observe why aerobic exercise improves cognition. BDNF is present all throughout the brain, and its abundancy is promoted by moderate intensity aerobic exercise. Low and high intensity aerobic exercise have been shown to have no significant effect on its abundancy. It is also important to note that BDNF is mostly concentrated within the hippocampus of the brain. This is important to note because the hippocampus is responsible for memory. Similarly, serotonin is present all throughout the brain, and it promotes cognitive function. However, it is important to note that it is unknown as to how aerobic exercise influences serotonin within the brain, as research has been shown to have contrasting information. With the gaps in my research highlighted, there are a couple of reasons why my research is necessary in order to further this field. The first of which being that higher level thinking is not observed in this field. Most research opts to observe how lower level cognitive processes, as the aforementioned inhibition, memory, and reaction time, are affected by aerobic exercise. Also, my participants have very similar characteristics that may affect the experiment's outcome. Most research I have read did not have controlled experimental criteria for their participants. And as mentioned beforehand, my study has applications for the real world. The question my study seeks to answer is what are the effects of varying intensities of aerobic exercise on higher level thought? As per a study I read concerning soccer referees and how moderate intensity aerobic exercise improves their memory, my null hypothesis states, if participants perform moderate intensity aerobic exercise, then there will be no improvement in testing performance. However, my alternative hypothesis states, if participants perform moderate intensity aerobic exercise, then there will be an improvement in testing performance. There were multiple different variables I had to account for throughout my study. The variable I manipulated was the exercise intensity. The dependent variable was the test scores received. The control was a lack of exercise done before a test. And some key variables I kept constant were the testing environment, the testing proctor, the test difficulty, and the time spent running. The first step in my study was to obtain consent for my research from Dr. Jones and Ms. Bowman. Afterwards, I obtained informed consent from my 10 participants and their parents. Afterwards, I then created 3 sets of 20-question higher-level thinking tests using Bloom's taxonomy as my justification. The test may be seen on the right. Before beginning my test, I gathered important materials such as pulse oximeters, as seen on the left, the test themselves, paper, loose leaf paper, pencils, and other miscellaneous materials. I then randomized the order in which my treatments would be administered, which ended up in the order control, followed by the moderate intensity group, followed by the high intensity group. Before beginning testing, I took a measure of my participants' heart rates to ensure that they were below the 60% threshold. After heart rates were recorded, I then passed out my papers, the test, read my participants the instructions, and gave them 25 minutes to complete the test. The testing setup may be seen on the top left. After the 25 minutes were completed, my participants were then brought down to the Bonner track. Here, they were instructed to run at a moderate intensity pace for 7 minutes. Both the picture on the right and bottom depict this run. After the 7 minutes were up, my participants had their heart rates recorded, and they were then brought back to the testing environment. Here, they were given the same instructions and given the same 25-minute time frame to complete the test. Once the 25 minutes were up, my participants had their test taken. After 10 days, my participants once again signed in and were brought down to the Bonner track. Here, they're instructed to run at a high-intensity pace for 7 minutes. Once the picture on the right depicts this. Once the 7 minutes were up, my participants had their heart rates recorded and were brought back to the testing environment. Once in the testing environment, they were given the 3rd test and given the same instructions and same 25 minutes to complete the test. The picture on the left depicts a student taking the test. Once the 25 minutes were up, the participants had their papers collected. I then graded the papers and compiled all my raw data. With my raw data collected, I then conducted statistical analysis. And 2 weeks after the conclusion of my test, I verbally debriefed all my participants. A graph depicting the scores my participants received after each treatment is displayed on screen. The first thing to note is that the control and moderate intensity groups are quite similar, besides the 2 outliers present within the moderate intensity group. When comparing the control and moderate intensity groups to the high intensity group, there is a visible difference between them. Within the high intensity group itself, there's all the scores counted as failing besides the top score, which was barely passing. With the knowledge of how my data appears graphed, further analysis is now possible. At the significance level of 0.05, I failed to reject my null hypothesis with a p-value of 0.87. This meaning that there was no statistical difference between the control group and moderate intensity group. However, the high intensity group, which was of no keen interest to me, provided statistical differences between itself and the control group and moderate intensity group, with p-values of 0.01 and 0.04 respectively. The data analysis provided information that contrasted my research. My research provided information saying that the moderate intensity group would provide an improvement in cognitive function. However, I found something that contrasted that. This may be explainable due to the proteins that I mentioned beforehand, BDNF and serotonin, only improving lower level cognitive function. Also, this provides implications for students, as they should avoid high intensity aerobic exercise before any academic activity. When interpreting the results of my research, some limitations must be accounted for. The first of which being I had no manner in which to control the pace my participants ran. Because of this, I had to use pulse oximeters. Though pulse oximeters are reliable, the time it took participants to have their heart rates measured may provide a lurking variable. Also, testing fatigue is another variable I failed to account for. On the first day of my experiment, 2 tests are taken, whilst on the second day, 1 is only taken. This may have resulted in the outliers present within the moderate intensity group. With these limitations in mind, I have some suggestions for future research. First, I would suggest future research probe further into how high-intensity aerobic exercise and higher-level thinking are correlated. Also, I would suggest using a different demographic and repeating the same test. I observed athletic adolescents, and there are a variety of other demographics, such as sedentary adolescents, available. Also, a larger sample size for more accurate data should be used. Throughout my time conducting my research, I learned a couple of valuable lessons, the first of which being test-taking skills. Since I made 60 different higher-level thinking tests of questions, I learned how a test maker may think when creating false answers. I also learned how to manage my time, with cumulative assignments being plenty and not many building blocks in between. Also, as a typically messy person, I learned how to stay organized in order to properly conduct my research. With that, I would like to thank some key individuals in the completion of my research project. I would like to thank Ms. Long for guiding me through the research process and providing valuable consultations with my experimental design. I'd like to thank Khalil Khan for providing the Danville Masjid and Islamic Center as the test environment. I'd like to thank my participants for their endeavors throughout my study, and I'd like to thank Nizar Rami for taking the pictures of my experiment. At this time, I'll take any questions.
Similar to a question that I asked earlier, do you think the conditioning of your participants could impact the outcome? Say a student who's well-conditioned, in good shape, do you think they may fare better on high-intensity participation on assessment versus someone who may not be? I know that the norm is the pulse rate, but I just get the question on that.
Dr. Jones is asking if the conditioning of my participants may have affected the
Outcome of the test.
Outcome of the test. To answer that, yes, I believe so. I tried to control that in some manner by restricting my sample to athletic individuals. However, I would have preferred to have a single sport because the conditioning of track and golf are so different. So yes, I believe so, because someone who runs track is going to be much more refined and less prone to getting tired. Yes, Ms. Wilson.
So I don't think I heard you say that you used a different test for each time they took the test. Was it the same exact test for each time they took the test, or was it different questions on each test?
Ms. Walls is asking if I used the same test 3 different times. No, ma'am. I used I created the first test of 20 questions, and then I modeled the 2 other tests off the questions, but they were asking different questions, if that makes sense.
Yes, so there's no opportunity for them to remember and memorize the answers and then go back and do it so that they wouldn't have to cognitively think. That's, yes, you controlled for that. Very good.
Thank you. Yes, Ms. Kent.
Did you make the test yourself, or were they sampled from other research papers?
Ms. Kent is asking whether or not I made the test myself. Yes, ma'am, I made the test myself. As mentioned, I used Bloom's taxonomy. It's a pyramid of higher level thinking, and I modeled the questions off of that pyramid.
Okay. Did you test your questions against each other to make sure that they were reliable and valid, that they could be standardized against all of your different participants?
No, ma'am, I did not consider that. Oh, I should preface for the crowd. Ms. Walls is asking if I tested my questions against each other. No, I did not. I just based it solely off the pyramid in my own judgment and Ms. Long's. Yes, Ms. Collins.
So when you gave your test, was this the same time of day, in the afternoon after school, or?
Ms. Collins is asking whether or not I gave my test at the same time. Though my research did not state a certain time to give the test, I still gave it at the same time, more so for convenience, but I still did.
So did you make any suggestions to Ms. Long about what y'all ought to do before you have a test? Should you relax or should you go run?
Ms. Collins is saying, did I suggest to Ms. Long whether or not we should relax or run before a test? Well, not to be a Debbie Downer, but Ms. Long's research class doesn't really have many tests. And I'm not sure if my classmates would enjoy a run. Yes, Ms. Walls.
So did you, tell your mom about the results of your experiment so that, you know, when you come home and you're not so brain dead, you know, she doesn't have to question you any longer?
Ms. Walls is asking if I told my mom about the results of my experiment. No, Ms. Walls, I did not, because I knew I would have gotten too much grief for that.